Welcome, everybody, to the Making Awesome podcast, Season 3, Episode 28, where we've got Dan from b.jetting. Dan, talk to us about really what you do, but before we get too deep into it, I need the Backstreet Boys out of you. The who you are, where are you from, the what you did, as long as you love me.
Sure. Hey Grant, first of all, let me just say thanks for inviting me on today. As you know, you'll find me in the chat of Making Awesome on the occasional Sunday whenever I get the notification and I'm in a position to take a listen. I always enjoy the show, so thank you for having me on. So I am Dan Bruner. I am former technical fellow for the exone company. I started there in May of 2001. I built their first piezo-based binder jetting printer known as the R2. It's a machine we finished up sometime in 2004 timeframe. And there are at least over a dozen of those machines still running all across the country today. Or at least there were a couple of years ago when I left X1, there were a bunch. So
now you have your own startup, right?
And now I have my own startup. So after spending 20 years at learning about all the things that I could possibly learn about binder jetting, I started my own little consulting firm, b.jetting LLC. And with that, I just, I did what you might imagine people in my position do. You take on a couple little projects here and there, get paid, and receive more money, and just kind of help people really solve their problems, which is really the important part. Is that I do get, it's a lot of money to solve problems. And but one of the things that kept coming up over and over in my discussions with customers and potential clients and stuff was this idea that they felt that they needed something, in-house that could help answer some of their questions. When people come to me for binder jetting, it's typically not because they've got a standard material or a standard problem to solve, because there are some great solutions out there from X1 and Desktop Metal and GE and HP and all these guys that make these beautiful true production binder jetting here. That's just some stuff, and I'm sure we'll talk about what those production systems are like later. But in the discussions I was having, it's always people who have something unique, something different, or they're maybe wanting to make their own binder, they're wanting to study a particular type of powder, and they've got some crazy idea that nobody in their right mind would be willing to work with them on. Because it's just so far out there, and over and over and over, just kept coming. They needed something small scale. They do some tests on, and they wanted to engage me. And of course, I didn't really have a big binder jetting machine at the time. I was mostly, doing things like writing articles and putting uses and helping people that did have machines solve their own problems. But I didn't have a piece of gear, so. My partner James and I just really kind of, I had this idea for a real small tabletop type platform, even just for our business. And the more we kept refining our ideas and talking and thinking about what this machine might be able to do, we decided, why not just go ahead and instead of making one for us, why not start talking about it to other people that have been reaching out to us and say, like if we were to come up with some kind of a small test platform that was affordable and modular and could do all these different things that you want to do, either research or testing or education, whatever it is, on this really small scale, is this something that you'd be interested in? We got like lots of, encouraging statements, let's say. And so we decided to go ahead and pull the trigger and start building a couple and see what could actually happen here. We wound up selling our first one to a little startup out of Nashville, Tennessee called Infiltrate 3D. They're
Can we talk about binder jetting for a bit? Also, do you mind raising your voice a little bit? The
audio's
audio's getting a little warbly in there from the chat, or closer to the mic for me. But because binder jetting is like, I guess, let me go through my understanding of it. I'm probably wrong, but this is my understanding, because I've worked with binder jetting, but not your binder jetting. Right. The binder jetting that I've worked with is CJP, the color jet printing from 3D Systems. That uses actual inkjet printer heads from an HP printer. Right. You're not doing that, though. Traditionally, binder jetting, to me, is more similar to polyjet from Stratasys, where it's a bunch of nozzles that are, pushing out that binder. Is that similar to what you're doing here?
But let's really think about that, Adam. What you're actually, or I'm sorry, not Adam.
Who's Adam? Now I gotta know who Adam is.
Adam Penna, right? Like he's the
Oh,
last, Adam and Alex were the last people to interview me. I apologize. Anyway, Grant. So okay, where was I? Okay, there's no difference. So in that case, in those old 3D Systems machine, they used binder. Essentially, what they used was like a lightly sugar-filled water, right? But what you're really talking about is the difference between jetting technologies, whether you're going to use a thermal inkjet printhead, or in the case of X1 and some of the other bigger metal guys, whether you're going to use a piezo-based inkjet printhead. So think like an Epson Echo Tank,
right,
versus an HP DeskJet, right? So really what you're talking about is the binder jetting applicator, the tool, let's say, right? Like
the
you're talking
thing
about
that matters. Yeah.
Right. Instead of the cutting tool, you've got the adding tool, right?
Because we've got the whole laying down powder done pretty well. I mean, the recoder, there's some magic you can do with recoders, but really it comes down to the actual binder that matters more, right?
It sure does. And as you know, working on those Z Corp machine, or I mean, I'm sorry, 3D Systems machines.
I mean, call it Z Corp. We all know
right,
what it is.
Right. Oh man, dude, I keep losing my train of thought. So, it's not as different as it seems. I mean, does the binder matter? Yeah, of course it does, but it only matters insofar as how you're going to configure the rest of the machine, right? Like we could back in the day. So back in the day, I'll give you a history story here. So like back in the day, in 2002, we bought a Z-Core machine thinking, oh, maybe we could figure out a way to put some metals on a Z-Core machine. And, like the business guys were all exploring how compatible is blah, blah, blah. And yeah, it turned out like it was just absolutely untenable. Like the binders that were compatible with thermal inkjets at the time were not nearly the kind of binders that you needed for metal. Yeah, super thin. It's like 98% water or something. And
yet it costs 28 cents a milliliter.
Well, you bring up an interesting point, Grant, and I guess I'll say that that's like a legacy, right? Like that, if you think about printers, like your desktop printer, it is entirely a razor blade model, right? Like they practically, that $99 or $199 you pay at Best Buy for your printer, that's basically the cost of the machine. And they're expecting you to buy a whole bunch of ink cartridges that are really high markup, and that's how they're going to make their money in the long run. And even if you look back to those old days, even like before we were X1, we were part of Extrude Home. You look back in those old days, and that was the plan, right? It was like, we'll sell the machine. We were thinking like printer makers rather than like machine tool manufacturers.
Right.
Okay. And so we were expecting to be able to do similar kinds of things. We'll sell this machine real cheap and we'll make lots of money selling powder and binder. But little did we know, the world of manufacturing is not exactly going to put up with the same things that the world of at-home printing does. And so you sort of saw an evolution in some companies and particularly in X1, where they kind of had to depart from that thinking, because it's not like you buy your Mazak CNC and then you have to buy Mazak aluminum and Mazak cutter heads and Mazak motors and Mazak wheels and bearings, like that isn't how that industry works. So to think that you're going to force your super highly priced materials onto this market where they're making millions of things at a time, you're just kind of fooling yourself.
Right. Yeah. But now the market's kind of adjusted to this. You get a machine, you're locked into that ecosystem because, and this is something that I believe people that do consumer grade 3D printing don't understand, that once you get above about $5,000 for your machine, walled gardens are seen more as a benefit sometimes than a detractor, where below $5,000, we want open source. We, nothing that we have to, pay to play. We want to be able to buy from whomever we want.
Right.
But when you start looking at things like a binder jetting machine, while we did crack the code for the Z Corp and we produce our own inks, don't tell 3D Systems. Not that they care, because I, maintain my own damn printers, but we're able to do it for less than a nickel per milliliter. And that is only because we're using very, very, very high quality dye in the actual ink itself. But when you look at binder jetting for metals, that formula is really the key and why we would choose to go with a walled garden. So it's not really seen as a bad thing in the upper end world. It's just the cost of doing business, right?
That is true to an extent. And what I can say is that in some ways it comes down to how efficiently your binder jetting machine is able to utilize binder.
Right.
What I'll say is that in some of my earliest platforms, there was no recycling binder, and probably 80% of your binder wound up in the waste bucket, and only 20% of your binder actually got utilized in the powder bed, because essentially it's glue, right? And so it's hardening and setting all the time. And so you're having to purge a lot out.
Yep.
Especially if you don't have a particularly good formula, which I did not at the time. But that was a completely different animal, right?
I know. It's the one tech that I have experience with, so I'm going to keep giving them shit. But, it is, because they're alcohol based. So the longer that ink sits, the more concentrated the colorant gets, which changes your color.
That's true too on those kinds of inks, and knowing the right kinds of alcohols to use and everything, it takes time.
But with the glue system, purging is an issue, right? And so
it is
on the consumer side, right? We don't really have glues. You have your main model material. If you're running a tool changer or an IDEX, something like that, you might have a support material that is looked at as waste. In powder printing, most of the time, at least in binder jetting, there are no supports, right? The surrounding powder provides you with your support material, but there is still a waste material, as, like you said, the print head needs to purge. You are doing binder recapturing, so it can be recycled.
Right. Yeah. So it can all be, so you get it at least to where you can reuse it. Like I say, early machine designs were very simple. You had a gutter, you squeezed a whole bunch of binder out, and you pumped whatever went into the gutter into a waste bottle.
Yep.
But now, now that we know more about binders, now that we know more about binder reuse on platform, and I mean the industry as a whole, right? Not just me, but like the industry as a whole understands it's better. Binders a lot better. Now we can make these systems where you can recover some of that binder that you're either spitting before or just purging before, mix it in with some fresh binder, keep control of a couple of variables that are very key, and you can recycle a whole lot of it, right? Like you're never going to be able to capture all of it, right? Like, 'cause you are, at the end of the day, you're squeezing some out and you're jetting it around and whatever. So you are going to have a little bit of waste, but the systems themselves have gotten to be a lot more efficient. And as they get more efficient, you can charge more for your binder, but you also sell less of it. So you have to charge more for your binder. So it's a circle or a cycle or whatever, a pendulum maybe.
Yeah, a pendulum's probably the right way to look at it. But something that I want to bring up here, because so far no one has figured it out, and I'm surprised, because I was expecting some sort of like you're doing what? Yeah, this is metal printing, and you're gluing pieces of metal powder together, and then you do either a sintering process or an infiltrating process with a carrier metal. With X1, it was normally like a brass material, right?
Bronze. It was a 90-10 bronze.
90-10 bronze.
Yeah. Which is like a typically found infiltrant in the powder metallurgy industry. The biggest difference is, like infiltration is the dirty secret of press and center.
Yeah.
That the way press and centering works, they press under enormous pressures in the mold and all that, but they only get to about 95% dense, and they don't move that number very much just through their sintering process. But in a whole lot of MIM lines, the last step is that there's a little like copper wick that hits the part on its way out the furnace to just wick up a little bit of bronze, or a little bit of like a tin bronze with some with some other metals in it that help with the infiltration. And that's common. And so it was kind of based on established technology. The biggest difference was that when you're done in an infiltration process, a metal infiltration process, when you're done with the metal print, it's really only about 60% base powder at that point. You know, like when you center the metal, there's very little shrinkage, there's very little actual bond to bond between the particles themselves. And it's really, you know, the thing is, the way to think of it, I think, Grant, is like as a cemented material. You know,
right.
It's almost like a cemented material.
And that's how we looked at it as well. So similarly, the color jet process requires an infiltrant.
Mm-hmm.
In our case, it's super glue. So we would go through about, I don't know, a few gallons of super glue a week.
Yep.
In b.jetting, what are you guys using as the infiltrant?
So, you know, I'm focused in the metals market, Grant. I am more focused in single alloy materials. So,
okay.
You know, I'm focused on the same thing. It's like in terms of my educator, you know, so like, well, I guess we can talk more about the difference from the products, but the educator is meant to be a basic, simple, you can print the standard 316s, the 17.4s, and the bonus material is going to be an Inconel 718.
Ooh, Inconel 718. We'll get to that in a bit. That's a fun metal to talk about.
Oh, sure. And so those will be the materials that you'll do on our system. And it's not because like we're masters of materials development. The reason we're choosing these ones is because they are so well understood. And there's a lot of resources that we can go to find solutions even to our problems, right? Like people have been sintering 316 stainless for a long, long time. And there's a whole network of furnaces out there and metallurgists that know what they're doing. There's powdered metallurgy companies that do this kind of thing every day in the MIM industry. So these are just understood materials. And here at b.jetting currently, we don't really have a materials development division, right? Like it's me and James right now. And so in terms of our actual ability to develop customers' materials, we really kind of don't focus on it. That's what we built platforms for, is to enable people to pursue the materials that they think are significant.
Okay. We've got a question in the chat. From Build on Sound. Also, we got a bunch of people here hanging out, and I guess we should do the housekeeping things, you know, like the stream, leave, you know, hang out with us in the chat, make sure you're subscribed if you're not, Patreon and all that kind of thing, linked in the description if you want to kick us a couple of bucks, as well as super chats available. But Build on Sound is asking, I got a question. Is it just one specific metal that you use, or is it a mix of different metals to give the best results? Or is this a no-go due to strength or chemical reasons?
So that's a fair question. I mean, so in a straight up typical binder jetting machine, like what I'm talking about, single alloy metal binder jet, center based technology, right? That is a single type of metal. Now, obviously 316 stainless steel is itself an alloy, right? So there's a whole lot of iron, but it's got all those other additives in it. So from a technology standpoint, what I can say is that, you know, the most difficult or uncentrable metals are pure metals. So like pure copper, pure iron, anything where you want to have a pure chemistry, that's almost impossible to binder jet, because binder jetting requires sintering. And the big difference between sintering and melting is that, like with sintering, what happens is that the particles are so small, and it only works with superfine particles. That's why we always talk about MIM size powders.
We're going to get to that in a bit too.
Yeah, 22 microns and smaller. But what happens is that, like, the surface area containing the metal is no longer able to contain the metal, but it doesn't melt. What it tries to do is reorient its amount of surface area with respect to all of the other particles around it. And it's trying to minimize its surface area. So
it's kind of wiggling at high temp.
Yeah. And at those necks where the two particles are touching each other in intimate contact, that surface area starts to spread between them. So they don't actually melt. They just like grow into melt. They don't melt. They grow into each other almost. almost. And so that's why you also see, Grant, so much shrinkage. Like in the infiltrated process, you only see maybe 0.5% of shrinkage. You just leave the voids because you're going to backfill it with bronze. But in the case of high density metals now, you're starting at this, 55, 60% dense. You go through this consolidation to surface area, and now you've lost about 20% in your X, Y, and Z, right? So it's a significant
That's
amount
a
of
fair
shrinkage.
bit of loss. That is, it's why I don't mess around with the sintering style, or
Yes.
with sintering style metals, because
yes,
you can do it. You can do it on FDM printers, right?
That's right. That's right.
The Virtual Foundry makes
has
filament. BASF makes
Virtual
filament.
Foundry has a whole solution.
But
they've just been talking about microwaves and all that stuff.
The shrinkage is non-controllable, right? You can predict it, but there are so many additional factors, like where it's located in the damn furnace, that will it gets complicated.
That is correct. There's a lot of things that are complicated about binder jetting and putting it into production. But what I'll say is this, Grant. So what I have found with binder jetting is that it is remarkably repeatable. And whenever I design a machine, and whenever I would design a printing process or a laydown strategy or a powder handling system or anything, all I strive for, I don't strive for perfection. I don't strive for perfect accuracy. I don't strive for anything but making it do the exact same thing every time I tell it to do that thing. It's all about making it repeatable. And so that's kind of that's my number 1, 2, and 3 measure of how good any particular subsystem is on the machine. Is if I tell it to spread this much powder, if I tell it I want 100 micrograms of powder, do I get 100 micrograms of powder every single time I tell it I want 100 micrograms, right? So it's really like that. And I found that to be true on all those things you're talking about. Like that, yes, you might have to do some crazy run on your big production machine where you've got to print all 29 parts in a very particular part on the bed, and then make sure those 29 parts all wind up in the same hot zone in the furnace that you're using. But if you do that, if you really set up and tune your process, you can come to a place where everything that happens around you is very repeatable. And at least you can count on it to do the same thing. It might not be the right thing, might not be exactly what you want, but you can get it to give you the same thing every time. So if you start from there, then you can find those production use cases. You just have to be a little bit more patient. And hey, I always told myself the same thing, even starting back from 2001, that today is the worst this technology will ever be. And no matter what else tomorrow, it's going to be a little bit better and a little bit better the day after that. And, that's what it is. It's just a slowly moving. And the thing of it is, Grant, I'll say too, that's another reason why, on my little platform here, The Educator, it's a small 60 millimeter cubic box, right? It's tiny. It's designed to be tiny, and it's designed to keep my customers out of trouble. Right. I always say, if you can't do it at 60 millimeters, making it bigger isn't going to make it easier. Right.
60 mil is tiny, though. And we had a comment early on that I'm interested to learn about all the things I can't afford. And The Educator is not. Well, okay. It is.
Well, it's a little unaffordable.
Well, it is affordable when you compare it to other things in the market. It is not affordable when you compare it to a $200 Ender 3 that can do 8 inches cubed, right? When you're dealing with a bit over 2. But for the vast majority of people that are doing metal binder, that are especially those that are in the research area or education, probably as the name states, are not really going over that 60 millimeter cube. Is that what you found during your time with
the thing of it is, if you look at what would normally be considered the ASTM standard for a compacted or min-made part, their basic spec is something like it was an ASTM B.213, and I think that it was like 1.5 inches long, maybe 1 inch wide and 1/4 inch deep, something like that. Like that was the standard bar that you could use
Okay.
to do green strength test assessments. And yeah, like I expect most people are going to print like 4 25 millimeter squares that go 4 to 6 millimeters deep, and they're going to be using small amounts of powder, trying to just, do some proofs of concepts of, is this centerable? Is it not centerable? Like what I'm trying to do is just set up more of a, a rapid application development platform, right?
Right.
Like I tried to make it highly configurable, modular, swap things out. People who buy into the alpha customer plan are going to get all kinds of access to b.jetting LLC and all of our designs for all kinds of different powders and spreaders and stuff like that. So it's yeah, so this isn't, so it's $100,000, right? Like the basic educator. I'm open about our pricing. We publish it on the website. It's $100,000 platform. You get 2 builds per day at 50 micron layer thickness, which, again, it's not the world's fastest machine. It's not designed to be. But it's an all-in-one binder jetting system. And this is actually Alpha 1 up here. Alpha 2 is down there. Alpha 1 is a completely special system for vitriform. So and this is just another example of how b.jetting works with its customers to try and find a place where you feel comfortable buying the platform. Right? You'll see. Right. So normally there would be a curing oven in here where you would put your, so binder jetting basically is a multi-step operation. You've got that whole printing step, which is itself a multi-step operation. Then you've got a curing step where you've got to set the binder. These binders are typically wet, right? Like they're printed, so it's all liquidy. You got to cook it out, dry it somewhat, cross-link if you're doing some kind of reaction, whatever. That happens in a curing oven. Stock Educator has one. This particular customer is using a material system that doesn't require curing, and they didn't require the depowdering system like normally there would be a fully de-automated powdering system here in the left corner like there was on Alpha 2. But this customer didn't need that either. They really wanted to focus on investing money in their platform where they wanted to do materials development. So we came up with a package for them that maybe didn't have all the things that a stock educator for doing metal would do, because they're not doing metal. But we were able to come up with a configuration for them to do the material they did want to do. And I'm actually allowed to say it's Vitriform 3D. They're doing glass powders. They're a little startup out in Knoxville, Tennessee. They're a graduate of Oak Ridge's Innovation Crossroads program. Nice. They were given a $200,000, whatever that's called, a grant or business startup or whatever. And they have 2 years to get to market. And, we didn't want to eat up a whole bunch of their budget. So we worked with them a lot to try and, pare this machine down and make it something that they felt comfortable, purchasing, that we felt comfortable selling. And they became the Alpha 1 customers. So, kudos to them. I'm really happy that they chose us. It was, there are choices out there too. I got to say, I always tell people, Grant, that I'm here for the binder jetting, right? I put over 20 years of my life on this, and whether my machine goes anywhere, hey, great. If I become a billionaire selling $100,000 platforms, if I don't, I don't. But I really do want to see that binder jetting be successful. I think it's great technology. I love the technology. If all I get to do is sell 4 or 10 of these and then I go back to just consulting again, that's fine. I'd love it for it to be more, but hey, what I really want to see is binder jetting succeed. And so I watch all these, there's all kinds of people in the news lately. This past Forum Next, you saw the debut of the Centerjet machine coming out of Turkey. We don't know much about the details yet, but we've heard and seen several press releases now from Foxconn and Trititive, Trititive being a Spanish company, Foxconn, of course, being Foxconn. And their announcements that they're working together to develop binder jetting platforms. We know HP is here. GE finally gave us the specs on the H3. We've all known what Desktop Metal and Exone have been building for a long time. Digital Metal now with Markforged. I think Digital Metal makes an excellent machine. It's a beautiful machine if you've never seen one up close and personal.
I never have, but I'm aware of it. The only metals that I mess around with often are LPBF. I have very little experience in binder jetting metals. And theoretically, you could run multiple different types of metal in a build, but then you would risk, obviously, mixing your powder. So if you did want to play in alloys, are you able to just, at a certain point, change it out for a different metal? Is that possible?
So I'll just say it's possible, of course, like, right. So like,
Mm-hmm.
so I'll just like say, so like, let's say I have, see, this is real, Grant. It's not just CGI. So let's say I have my powder dispenser here and so like my system is based all on cartridges and various types of recoders that you can use. But the idea about making it clean or swappable, okay, well, so I have this recoder and I've got my powder in there, and okay, it's layer 227. I'm going to change. Well, I just pull that one off, and then I pull the one out of my desk here, and this one has my special fairy dust powder in it. So now we'll put the fairy dust in there for the next 50 layers or whatever. So yeah, it's certainly possible. You do wind up with, then, as you might imagine, when you go to depowder that,
your recovery powder's completely mixed.
Yeah, you would have to have a way to, like, now, if it happened to be too really easy to separate materials, like if you happen to need iron and aluminum, that'd be great.
Yep, big ass magnet.
That's right. So, I suppose there are solutions that make sense, but hey, listen, I'll say this too. That's oh, geez.
That's kind of what the platform's for, though, right? It enables people to test and learn, because 60 cubic millimeters is not a ton of material. And to be clear, this is like sub 20 micron powder of metal. Okay.
Yes, that's right.
So yeah, there is a cost to it.
Sure.
But like the cost, last I checked for TI-64 titanium for LPBF was like $10 a pound. It's not expensive.
It's not as bad as it used to be.
No.
Now, titanium, I would think, might be a little more than that. But, I know that certainly, like a lot of the MIM grade. Hey, listen, here's the thing. This is why binder jetting always tried to use MIM powder. MIM powder is a commodity. Okay, like there are gazillions of tons of MIM powder used all around the world every day. Laser powder bed fusion powder is actually a special cut, right? Like it's got a much narrower range of acceptability. It's usually more like a 10 to 40 kind of a thing, maybe an 8 to 35 or a 5 to 32. But like, it's a less commercially common cut of powder than MIM is. And so binder jet, that is. So like what you're imagining about the prices of laser powder. So now like take 25% off of those again, because they're just so much more common. And there's such a great, wonderfully competitive landscape. And, so like you'll see a company like HP partner kind of exclusively with GKN, right? And they're really kind of honing their system in. But GKN sells metal powders to other people, and there's lots of other metal powder producers besides GKN.
Right.
So, and I'm a big believer that one of the things that's really helped the industry along actually is that competitive marketplace for powder. I have friends in the industry. I have people I respect. I'm going to name drop my really good friend Ben Farrar from Carpenter Powdered Metal, who is one of the earliest people to kind of start working with b.jetting LLC and developing our metals capabilities and metals testing capabilities. He and Philip from Granutools were some of the earliest reach outs to really help us develop the metals that we're going to be launching with. But that said, and Ben would understand this too. He would understand that as much as I like him, I do have to be agnostic. Some of these powder metallurgy companies that you see having successes with binder jetting now. So I mean the Azos of the world, the Freeform 3D here in St. Mary's, some of these bigger players that you've heard of. That are not X1 and Desktop Metal, like their actual customers that are successful. Almost all of them, if not all of them, have a pretty deep, rich history of like that they view this not as a displacement technology. They view this as an enabler of new markets for them. They view it not just prototype, but they really do view it as true bridge type production. Like those people are out there right now. Those people that have that deep metallurgical experience, they right now are already being successful. And what we're hoping with a simpler, smaller platform like this is that we can help, smaller players be successful. find a way to be successful, find a way to get started. But by the same token, Grant, at the end of the day, this is a complete binder jetting platform. So like, who knows? Maybe I'll sell one to GE because they don't want to tie up an H3. Yeah, right. They don't want to tie up an H3 to go research some powder, and maybe they never made something super small. Who knows?
Even further, they may not need a big build volume. Like this is something that doesn't really work on the FDM side because like you just don't print where you don't.
Right.
But if you've got a huge build volume for a powder printer, you must fill that entire build volume with powder.
Exactly.
You can't get away with just the amount of powder that you need for your build. So when you start looking at things like expensive, Inconel 718, stupid expensive, or you look at maybe some form of a gold or a precious metal, you want the smallest build volume you can possibly get. So if you're not going to use it, why pay for it?
That's right. And the bigger your platform is, frankly, the dirtier it gets, right? Like every nook and cranny you add to your machine is another nook and cranny that's going to fill up with powder.
Okay. So I used to run 5 of these CJP sandstone printers, and I was working for somebody else who would not let me wear a respirator. You can see where this is going.
Yeah.
I went to the doctor for a routine check. I was coughing a lot. He asked me, "Have you ever smoked?" I said, "No, never smoked a cigarette, let alone anything else in my life." He's like, "Why are you lying to me?" I said, I'm not lying to you. He said, "Well, this chest x-ray says otherwise. It looks like you've been smoking for longer than you've been alive. What's going on?" I said, "Oh, yeah, that's probably gypsum powder." He said, "Grant, you're going to have to keep talking to me about this. I don't understand." I said, "I work in a powder environment and I'm likely breathing in the powder." He said, "You need to stop whatever you're doing and stop very quickly." And it was within 2 weeks that I had said, I'm done, I'm out. Yeah. And then we started, you know, when I then started 3D Musketeers, we took every ounce of safety, right? In its own room was under negative pressure. You know, you had to wear a respirator when you went in there. So metals, though, totally different animal, right?
Well, it is different. So, and again, it's going to depend upon, you know, which size you're working with. So like, if you think about the infiltration metals, right? Like the ones that are a little bit too big to be centered. So we infiltrate, so you infiltrate with bronze. You know, the nice thing about those is they really drop out of the air. You know, like they don't float. They're not like that gypsum powder where if you had a spill and it just starts pluming out and stuff like that. So a lot of the metal powders that are in common use, you know, they drop pretty easy.
Yeah, they're dense. But you still don't want to breathe it.
But you still don't want to breathe it. There's still nickel in there, right? There's still all those other bad things. Some of these finer MIM powders, you're exactly right. You definitely do not want to breathe. I mean, like there's a reason why these people that you see in the big production suits, they aren't just wearing respirators, they're wearing active purge bunny suits, right?
Pappers and that kind of
right. They've got pappers and all that stuff going on. So, you know, there's a reason for that, certainly. And, you know, I'll just go ahead and plug the educator here. That's one of the things that I've been very conscious of. And so like around all the build boxes and everything, there is like active powder collection. There's vacuums that are all strategically placed behind the machine to keep pulling the dust out of the air from in the chamber and collecting it somewhere so that you can reuse it easier, but also because, you know, hey, in addition to health and the health reasons should be enough. But this is a capitalism. So it's also, if I let that powder float around inside my machine, it's going to waste money. It's going to wear the bearings out faster. It's going to wear the motors out faster. I'm going to lose print nozzles, you know, like keeping it clean is critical.
Like gypsum powder just kind of got stuck to the edge of a bearing wiper and that was it. If some got into the bearing, no big deal. But, you know, steel powder getting into a ball bearing, probably not good for its health.
Hey, and not just that. The thing of it is, Grant, Okay, so like let's just keep free forming some great things about binder jetting here. So one thing about binder jetting that's great is that sintering is fundamentally completely different than welding. It, like selective laser melting or laser powder bed fusion, that you've got to be using a weldable material. And one of the most popular ones, Grant, that you've seen, different press releases in are materials like silicon carbide.
Yep.
So now we're not even talking, a steel powder. Now we're talking about the hardest, most abrasive man-made material in sharp form being loaded into your highly precision binder jetting machine. And I mean, that kind of a powder can, kill up your bearings and weight. So, these are all things that you really have to take seriously when you're designing a binder jetting. Well, I suppose any powder handling platform, it's true. But yeah, I mean, it's particularly so in binder jetting. And again, because your work item, that is your printhead, right? Like your tool. That's got to be, as you know from Z-Core, that's got to be right above that powder bed when it prints. It's not like a laser where you've got some focusing lens a meter above the bed and blah blah blah, right? You've got that thing right on top of the powder.
Yeah,
it's like millimeters.
Maybe a millimeter or two.
Right.
Because the further away you are, the less accuracy you get.
Exactly.
So you want to be close. Can you tell us how far away the nozzles are for the
Sure.
educator?
So on the educator, I'm designed at 0.8 millimeters. Woo! Now I may have to come up a little bit from that because that's going to be, but I have some other technologies that help that work. But yeah, I mean, like I'm a big believer that you get as close as you can. And the thing of it is, it's because you get all these, like in digital printing, you get these crazy things like stringers and satellites. And, one of the crazy things about droplets is that, if the drop gets too small, it has like a negative terminal velocity, right? Like that's why you see mist just float away rather than fall to earth, right? Because that's what happens. And so, you want to be all the way up against that powder bed as much as you can so that you just don't have space for those bad things to happen. And it's really hard to stay that close. And again, that's why I kept it small and like compact like this, is because it's very easy for me to create a device that can travel at plus or 5 microns across 60 millimeters of surface. That's easy. Trying to get something go plus or minus 15 microns across a meter of surface is, a struggle and a half. So that's another reason why I kind of kept this small, so that I could make in terms of how precise I have to make it, since it's only operating over this big of a volume, I can really get some good precision because I only have to be this precise over this size.
Interesting. So when looking at the droplet size, turbulence must be a problem. Madcat is asking about this. How do you avoid that turbulence during the
flow? So like it's being close to the powder. So if you think about
no turbulence.
Let me just whip this out. So if you think about a printhead, let's just pull up. So if you think this is like a module carrier, okay, so like inside that slot, you would have some type of industrial printhead, right?
Okay.
So if you think about what's happening here, essentially, this guy, as it's coming across the powder, we try to keep it super close. And so what you're trying to do is push that turbulence ahead of you, right? So like you have this wall hanging down that's well above you, that's well in front of the jets. Mm-hmm. And so you're trying to push that wall ahead so that it can't interfere. And like I say, this gap is tiny, like it's a piece of paper thick, kind of tiny.
Yeah. 80 microns is human hair, basically.
800. 0.8.
Oh, 0.8, sorry.
0.8, yeah. So it's very small, but still small, I gotta say.
Madcat has like the same question I have. That part's 3D printed. That copper part is FDM.
Of course it is.
Okay.
Of course it is.
It looks like a lot of that's FDM printed. Are those end use
Of course it is.
FDM
Of
printed?
course they are. Of course they are. Now these were prototypes. Okay,
okay.
So like nothing on the machine is actually made of this. This was like for me to get through. But yeah, no, like if you can't really see much on.
You're like me. You like the crazy colors. Okay.
Well, actually, the thing of it is like some of it's just I just want to see. I mean, we did. Okay, I'll get to the colors later, but you know, the thing is, Grant, I think that this platform is the perfect use case for additive manufacturing. I don't make millions of these, but I need free form complex shapes. So like, you know, if you're trying to connect this powder overflow vacuum system to some vacuum deep down in your machine, and you've also got some kind of separator there to separate the air from the powder, you know, like being able to just like design those things and then print them, I have them. And then if they don't work, I redesign something else and print it again. But what I do for the production machines is I do everything out of that. You actually recommended it to me, that EDX stat.
Oh, really? That's working out
what
well.
Do you call it? What do you call it?
Yeah,
the static control,
the electrostatic, the ESD filament from 3DX Tech.
Yeah. So nice. I'm getting so I do everything in that in the production because I don't want there to be a static issue. Not really. I mean,
compared to PLA, compared to the silk PLA you're using, there it is.
So let me say this. So okay, I'm going to go ahead and drop another name here because I'm that kind of guy. But you know, I buy probably all. I can't say almost at this point. I buy all of my filament from Matterhacks, right? So I'm not out there looking for the lowest price. Generally, they take really good care of me from a customer care standpoint.
Mara's awesome.
Mara is like fantastic. She's like one of my top 3 favorite, maybe top. She's way up there in my tops of the world, and so I trust her. Right. Yeah. So, and I know that you should never pick favorites and never say, and I don't pick favorites. But you know, like I just don't like know anybody from Dynamism anymore. I don't know anybody from some of the other distributors, but I know her and I know her people and I trust her. And so I trust her people. And it's not that anybody else out there isn't trustworthy or isn't every bit as great as Matterhacks.
No, but that relationship already exists.
But that relationship exists. And so it's nice and it's comfortable and it's, you know, and I feel good about every transaction. And so, and especially right now where I am as a company still really coming out of the gates. I mean, I'm only doing these 4 alphas this year and I have very modest growth plans and all that kind of stuff. So, you know, it's like, that's the kind of company I'd rather have rather than, you know, some nameless, faceless Amazon distribution.
3DX Tech used to be, you know, a guy named Matt ran it and they were bought. So they were bought out a while back. So I don't know if Matt is still running it, but you know, it's different. Or they have their HT2 printer that they're working on. But like I told you, we use them for all of our exotics, and it runs incredibly well.
Yeah, I've been very happy with it. But, so to continue on with some of that discussion, though, yeah. People who buy my alpha, it's better than that, Grant. People who buy the alpha, they get all these design files. You know, like one of the key things here is I want it to be a research platform that doesn't cost you $1 million to run, right? So, you know, and I wanted to make it easy. You know, one of the big complaints people have that want to develop powders is how hard an industrial binder jetting machine is just to clean. Like if you have 3. Oh, it's an 8 to 16 hour day in metals. It can be a couple of days if you're dealing with those super big sand machines. You know, it's very difficult. And so what I tried to do here, again, keeping it small, keeping it somewhat simple, and keeping it like publicly accessible. If you got a little, you can make a lot of these parts on an ender. I don't necessarily recommend it, but you can. You know, don't clean it. Set that in a drawer, put it in a bag, print yourself a whole new set of stuff for what you want to research today. It's a couple of bolts to put the new thing in. And then when you're done there, take it all out again. I mean, like, you know, the total cost of the filaments in the whole machine is probably less than $50 if you used a regular off the shelf cheap But I mean, of course, obviously use the 3DX stat.
Yeah, anti-static is a big deal.
Anti-static you do pay for. Yeah. And if you want like it's definitely worth it. If you want like a CF carbon fiber conductive, that's going to be even more. But, but that's the idea here, is that like I'm going to share these things with my alpha customers. Like it's not just going to be me from up on high. This is everybody that I'm talking to that's thinking about joining, and I say joining like it's some kind of club. I guess it is maybe, but it's like people who want to come along on this alpha journey. It's a journey, and this is, and I always say this is alpha 1 behind me. This is alpha 2 on the floor. I'm looking for homes for 2, 3, and 4, and I'm going to build 5, so I have one. And it's going to be like a 6 to 9 month learning about the platform, designing things for the platform, extending the platforms, working with my customers, figuring out, do you like this feature? Do you not like that feature? What needs, and it's going to be a time for all of us to, like really wrangle this out. I have plans. I want to, like maybe have a beta by AMUG next year. We did our alpha this year. Maybe I can have a beta done in 1 year, maybe, and like maybe 2025, we're talking about getting into 100, I don't know. But, I'm trying to do like a really stage gate approach to this, because I really want the machine to be a great machine that people like and use. And so, I'm like kind of only allowing us to sell 4 this year, because the people that sell this, I want to have, like a really deep relationship with, like I really want us all to be successful. And I don't want to have 12 people. I want to have like 3, 4, enough so that we can really get it launched, keep us going for the rest of the year, and all that kind of stuff. And just at the end of that, we're going to have this alpha that we've all been working towards making into a beta, and it's going to be great. And and it's just going to be something that I evolve slowly here over the next couple of years to really turn into really, I mean, hey, like everybody, I want to sell and make the best in my class device,
sure
right?
that your QA and QC don't suffer by growing slowly. We have talked about this so many times.
No, I want to make sure I don't suffer by growing fast.
Right.
I don't want to grow too fast.
Dude, it'll kill you, right? Yeah. You need to grow at a rate that is reasonable, sustainable, and realistic. Because if you don't, you're going to outgrow your own capacity and then get pissed off clients because they can't do anything.
Exactly. And that's why we're only taking on so many. And, and James and I are self-funded, right? So, I run a consulting, as I said, in addition to this for other people. And it's really about reinvestment. It's about taking what we earn and reinvesting into the company and really developing this product. And so, it's a little bit of a scary ride, but it's really cool too.
That's the fun about small business, right? So what really pushed you to get into this? I mean, obviously your background is metal binder jetting, but what pushed you to say there's a hole that needs to be filled here?
Like I say, it kept coming up over and over in conversation, Grant. It's like, I was approached by several different companies that are interested in making their own machines. And and they would have something that they'd cobbled together from. So I'll say that out in the 2D printing industry, you can find relatively simple off the shelf, well, not simple, but you can find off the shelf like printhead evaluation systems from people. Okay, like different printhead manufacturers, like Fuji makes one. There's a company in Israel that makes one. They're called Pixtro, but it's a 2D printing test stand. Okay. And what you will see out there are some people have bought these and then tried to put their own little Z-axis in it to try and get this 2-dimensional press. And I kept running into those with my customers where this is what they had done. They had taken one of these 2D test stands, tried to put a box underneath it. We're trying to do some good research or whatever, doing the best they could with what they were able to find and source. And, it just kept reinforcing for us that, there's a market. And the thing of it is, Grant, I don't want to say that like I've isolated the market, right? Like, when you look at the binder jetting industrial landscape, you've got 25 and 160 liters from X1. You've got a little under 1 and 50 liters from Desktop Metal. You've got, I think it's 33 or so liters from HP. You've got 125 liters from GE's H3. And I can't remember the size of the digital metal. It's not nearly as big as those ones, but it's a good 160 by 160 or so, or maybe a little bigger. So your only jumping off point is into something, you know, significantly larger. And so I said, well, you know, like that space is all covered. Why would I go make a 70-liter machine? Like, what am I adding? Even if I made a 15-liter machine, like, what am I adding?
You wanted something sub 1 liter.
Yeah, I wanted something sub 1 liter. I said, well, you know what? Like not the problem, but one of the realities with those large binder jetting machines right now is that they're not widely suitable for everyone, right? Like, sure, Ford can buy 10 $2.2 million P50s, but there's only one Ford in this world. There's only one Stellantis. There's only one Boeing. There's only one Cat, you know? So it's like,
unless you're going to make your money on an ink market, right, or a razor blade idea.
Well, and they have solutions, like I say. So you've got Desktop Metal, you've got X1, you've got all these other big production players who that's what they really want to do. Like those guys really want to make these big production binder jetting systems for making millions of parts. And I think it's great. I mean, like, I love it. It's great. I don't want to do that though. You know, like I want to make a little machine. Like right now, literally, you know, like I build each one by hand. They're, you know, I make them with, I pack the love inside, you know, right? It gives me opportunities to work really deeply with some of these initial customers, which is something I've always liked as part of my job. So, you know, this is just really putting me in a great space right now, both, you know, from a business standpoint, because I think, you know, we can sell these and we're going to make it for a little while here. And it also just puts me in just like a great headspace, right? Like where I'm loving what I'm doing. I love that I'm getting to pursue my dream for a machine, you know, rather than somebody else's dream for a machine. And so, you know, it's, yeah, I mean, it's just, everything about it's great. And the market reports that you read from groups like AM Power or like Barnes Global or these people that analyze these things, they all say the same thing. You know, like it's been a year of binder jetting for like 3 years now, right? So and it's got really great growth opportunities. And I saw Rick Phillip at AMUG last week, and I said, "Hey Rick, I tell you, man, I'm going to sell more P50s than you will. I promise. Like, I'm going to make sure that everybody gets like this great start, and they're going to come seeking out. Oh, yeah, you know, wait, this is binder jetting. Oh, you're right. Those production systems are worth it." So, you know, and I'm a plain dealer, right? Like, I mean, I love everybody's machines. I love my machine. I love their machines. We're all here, you know, like looking for different
cool
things.
Stuff. We like binders, we like jetting, and
and 3D in general is so cool. So.
I just love that you're using FDM in your binder. I have to ask, what machines are you using to make those parts?
So my parts right now that I make here are made on garbage.
Tell me you're running Enders.
I have an Ender 3 and an Ender 7. I have an Anycubic Chiron. I have an artillery, the big one.
Yeah, it's 16 square, I think.
It is, yeah. And I don't like it.
Nobody does.
I have that artillery sidewinder X2.
Uh-huh.
And then I have this one from Chitty Tech that I don't use. It was real small. It was my first one. I wanted to see what FDM was all about. It's like one of those 6-inch kind of box.
I like you're not using something like a Stratasys, you know, F370 or something.
No, I'm not. But I'll say this. I will say this, Grant. Whenever I do make true production parts right now, because I don't have one of those machines, I'll just go ahead and drop another name. And I want to say to all your listeners, there is not a soul who sponsors me. I only talk about people that I like and that I have.
Not a soul that sponsors us yet.
What's that?
Not a soul that sponsors us yet.
Right. So you know, I actually get my commercial printing done usually by Xometry, because they do run those $150,000 Stratasys machines. And I'll say their parts are much better than mine. I would hope.
Give me a holler next time you want to see.
I do. Grant, the thing is, I forgot that you do it commercially too. And
I want to try. I want to see where I land
quality
up against a $250,000 Fortis 250 or something.
Sure. No, I do. I do want to have you do some parts for me. And just show you how they're simple. But no, I do. I the thing of it is, it's like again, okay, so let me just like back up even more, so like as you know, or maybe not know, like I am more of a truly like a general purpose all around engineer. I'm actually a physicist by training, right? I'm actually an engineer by training. And so I have a lot of jack in the box jack of all trades kind of skills, but I'm not really good at any of them all that well. So like I can design. I designed all that. I had a helper, Olivia Kruger, formerly of
she works with us. I know Olivia well.
Okay, right. So she helped me at a really critical time, helped me figure out something about the transmission. And but other than that, I've designed everything there, but I haven't produced a single drawing because I suck at drawings. I don't even know how to do drawings. I know it's a whole science called GD&T, and people are excellent at it, and I am not. But so I use groups like Exometry because I don't have to provide drawings. I can send them my model file. They know what I want, and they just send it to me. And so, okay, it has some kind of general tolerancing of this, that, and the other thing that is probably some subject that I don't understand. But luckily, there are things I do understand, and I'm a master machine assembler and builder as well as designer. So I know how to take this pile of parts. I know how to hide a 0.5 millimeter there. I know how to put an extra millimeter here. I know how to tune the things and align to stones. And, I know what I'm doing from a machine setup standpoint, that I can take a fair amount of whatever imprecision and hide it, still make it all work, lock it all down, get it all right. And, that's just one of my many skills that I've been able to develop over the last 25 years in industry, is that I know how to assemble a machine in such a way that I don't have to make the G and D the most critical part of it. I just have to know what I'm doing when I put it together. And again, that's why I've limited it to 4 for this year, because it is there is a certain element to this that it all works and is all really great, because it's my hands turning bolts. And that's something that, will change. Obviously, I can't assemble every single machine as the company grows. But right now, being able to do that, where I just have to say, hey, this is what the plate has to look like, and these are where the holes are, and it comes in close enough, I know how to get it from close enough to perfect, and nobody will see a thing, right? It won't matter at all, those little imperfections. So obviously that's not sustainable forever. But
no,
as we get out of this initial growth phase, get these first few, it's going to serve us well, because we'll get where we need to be by the time we're really getting into
that's what matters. Just kind of getting to where you need to be. I like that, one of our resident trolls who's actually giving us real good stuff today, Worst Peter, great guy, he's in our Discord Patreon member and all that, says, I'm not that good at the stuff I do, builds metal binder jetting printer. So yeah, give yourself a little bit of credit there. But price point, right? A lot of people here are like, $100,000. I don't have $100,000 spent, because I don't have $100,000 to spend either.
Me either.
But let's look at competitors. What are competitors pricing at? In this market?
Sure. So I tell you the toughest competitor. We'll start with Centerjet out of Turkey.
Okay.
They make a fine machine. 160 millimeters long, 60 millimeters wide, 60 millimeters deep. So essentially about 2.5 my volumes, right? Yep. More or less, somewhere in there, almost 3. 65,000 euro. It's a really capable machine. It's now mine, as you might see, is what we would call an overhead recoater. That is, that it has some amount of powder in it, instead of the old Z-Core where it had that box that would lift up. Oh yeah, that's right. They had dump and spread too.
Yep.
But I was thinking more okay, so it maybe never saw some of the really small ones, like the 200s and the 300s. I had a 305, I think they were called.
I had a 310 for a bit.
Or a 310.
It came up.
It had 2 pistons, right?
Yeah, it had 2 pistons.
So that's what the Centerjet machine has. It's a 2-piston system rather than an overhead recoater system.
Way more powder.
Well, you need more powder. I mean, obviously it's a bigger build volume. So yeah, but yes, you need more powder. You're going to be a little bit more, excuse me, limited. Like MIM powders do not do great spreading box to box. Not like, and it's weird because gypsum really does. And, you know, I remember my 310 spreading a layer of gypsum, and it was like, you know, like you're waiting forever for the print head to do its thing, and then
yep.
Yeah. It's like, whoa.
We tried to break that formula and we never could. It's a specific granular size and it's not pure gypsum. There was something else in it. It's like an anti-caking agent that we could never figure out.
Yeah, well, I happen to know that formula exactly these days, but that's a different talk.
Well, then we should talk.
No, I would never, you know, like there's some secrets that I got exposed to in the course of my work that are really good. Hey, and listen, I got to keep on 3D Systems good graces. You know, maybe they buy me something. You know, no, I'm kidding.
I would love to be in 3D Systems good graces, but I'm fairly certain I'm not.
Well,
but they do make good machines. It's just I came in from someone like I started 3D Musketeers, someone that has enjoyed the non-walled garden consumer industry, and then looking into the industrial industry that's fully walled garden. Really, the thing that upset me the most was service. Right. Looking at this, you know, a Z Corp 650, ProJet 660 Pro are going to run you close to 100 grand by the time.
That's right.
That's 86 grand delivered with material. If you wanted an external depowdering station, that was another 5 or 10 grand if you didn't buy them used or whatever. Yeah, so call it 100 grand all in.
Yeah.
Well, then it was $9K a year for the service contract, and they had a 3-week response time. So we would be sitting, twiddling our thumbs, watching us just burn money for 3 weeks until the machine could get serviced. Service contracts are a big deal. Are you doing something similar with b.jetting?
Well, I imagine, you know, so, I mean, as you could imagine, Grant, I'm not a very complicated company right now. So when it comes to like these first 4 alphas, you know, what I've told customers is you're buying like practically unlimited access to b.jetting LLC's consulting technologies for the next 9 months. So it's like, you know, you're going to be the most, you know, cared for custom, like you're the first 4 people that buy these alphas, they're the most important customers I'm going to have my whole life, probably, right? So you know, it's going to be like that in the office. I imagine, you know, when we're past beta and we're doing serial production machines, let's say a few years from now, I reckon, Grant, I'll look like a whole different company. You know, I mean, like, I reckon I'll have 15, 20 people. I'll have a couple field people, I'll have some sales people, some marketing people. I'll probably have to have an HR person, probably have, you know, I mean, my hopes are to be
cat.
Yeah, right. I mean, like right now, well, so like James and I are like, so I'm all of our technology and procurement. So like I'm responsible, of course, for all the engineering, design, finding suppliers for the parts, getting the parts on order, all that stuff. James is responsible for everything: marketing, sales, paying the bills on time, getting contracts executed, you know, like finding new places for us to go. James is like a 35-year vet in the 2D printing worlds. I mean, so he's from Fuji. Let me just tell you a little bit about James. James Gill. He's from Fuji. I mean, but he wasn't just from Fuji. He's from a whole bunch of like ViewTech and other big 2D format guys. But he was, the way I met him, he was my, I met him as he was the field sales rep for Fujifilm Dynamics. I started using Spectra printheads somewhere in the 2005, 2006 time frame. That's when we first met. And, you know, he was just a great guy, worked together a long time. He was also then, as part of his work for Fuji, he was in charge of their 3D printing division as it became clear that they were becoming the market leader because, you know, Desktop Metal will openly tell you that they use Samba, which is a Dynamics technology, or Fuji Dynamics technology. I think GE will openly tell you about their use of Fuji. HP obviously is using their own printheads. But you know, there's a whole, but I think that like all these other companies, material jetting and binder jetting would tell you who's modules. And that's not to say that Ricoh modules aren't great, SAR modules aren't great, Kyocera modules aren't great. They're all great. And it could just be that Fuji was there with their foot in the door first, trying to get into this market rather than just like taking it for granted or saying, I'm a 2D printing company. I'm not gonna, what do I care about you 3D binder jetting people? Because that certainly was a lot of the response I got in 2001, I'll tell you that.
Wouldn't surprise me.
You know, so Fuji was really kind of, so Fuji was kind of the first to recognize, well, you know, maybe we should service this market in particular. And they were successful. So he comes like kind of from that background, and what that really brings to the table for b.jetting is, you know, James has like a super deep, rich history and knowledge about products and services that are in that 2D print space that are really applicable to what we're doing.
Right.
You know, pumps, fluid monitoring, formulation, chemistry. These are all things, they're all the same. And you know what James brings to the table now is not just my 20 years experience doing this with binder jetting, but his 35 years experience of doing all kinds of industrial printing and industrial jetting, inkjet jetting applications. So, you know, we have a really broad portfolio of companies that we work with, that, because hey, I get stuck too, right? Like I know a lot, but even I need help sometimes, or maybe there's a specialty application that, you know, I don't want to have to make my own whiz bang for doing some kind of crazy thing to a waveform or whatever. So, you know, being able to tap on this network of suppliers, and then, you know, some of the new 3D people are pretty awesome too. Some of these new software companies like Dendrite, these guys that do voxel processing specifically, and you know, it's just really kind of, the whole industry is kind of growing up, and I don't know, man, it's really been great to ride along with it too.
It has.
Sorry, I'm just kind of scattering around in 1,000 directions there.
Buddy, this is like you've been hanging out in the comments for enough of these episodes to know it is always scatterbrain, because it isn't always an exact answer. There isn't always a perfect solution. There isn't always, you know, one method of doing things, but the future here is really the crazy one. Because there is a huge future right now, isn't there?
Oh, I think so, Grant. I mean, I think that the reason that people talk about binder jetting so much is because everybody can see the potential. You know, like there's obviously some economics that you got to work through. There's obviously some technology challenges, but you know, people are seeing it finally. The one thing I give Desktop Metal a huge kudos for is they really elevated the entire industry of binder jetting in terms of getting it to bubble up into the public psyche. It's like, you know, after DM finally hit the scene, people would come to our booth and they, no, Desktop Metal does like what we do. And but you know, it was really them. It was really their consistent marketing of all the benefits of binder jetting and their single pass jetting technology and all that stuff. You know, like that really just elevated binder jetting in people's minds. I mean, like X1, we just weren't getting it done. That how whatever their mystical magic was that really got the word out, so to speak. They really did it. Like they did that yeoman's work of really bringing binder jet into the public psyche.
Do you believe that binder jetting is going to be a big future of, you know, what's going on out in the metals industry?
Yeah, I do, and I'll give you a couple of reasons why, Grant. I think that, you know, one, like I say, because of the material flexibility, right? Like, hey, digital castings is already probably 90% these days in the United States. If you're pouring an aluminum casting and it has any kind of a core in it, there is a 90% chance that that core was printed on an X1 binder jetting machine, not manufactured the classical way of making sand casting mold cores. So, you know, like it's already come in some way, right? Like metal binder, I mean, sand binder jet for metal castings is real. like, and it is real and it's big and it's awesome. So metals, couple reasons why. So one, like I said, materials that you can do, the non-weldables, opens up a lot of things. You've got that option for infiltration that opens up different types of metals with some fairly unique properties. And you've got speed, like two-dimensional printing, especially, like that single pass jetting, what desktop does, or, like you're not going a vector at a time, right? You're not squeezing a little bit of material. You're not running a laser beam. It's a huge blanket of material at a time. So there's always going to be that speed advantage. And, one thing, and it's scalable, right? Like, obviously, I can make a machine 60 millimeters big. They can make a machine that's 1.5 meters big, right? Like, it's scalable, and you can operate on almost any scale, as long whatever you can afford. That's the scale you can operate on. But where I think it's real future lies, Grant, and not many people agree with me on that. Pretty much nobody agrees with me on this, but this is what I kind of believe. So before, I came into additive, I used to be an automation guy. Like, I used to design assembly lines. I used to make control systems for assembly lines. I used to do high-speed assembly operations and automotive and trains and all that stuff. So, like, that's what I used to do. And what I'll say is, when you go into you'll see some kind of crazy new press release from Ford, right? And you'll see, like, in 2012, you'll see a press release. Ford's going to invest $100 billion into these 3 facilities to make the 2017 line of Ford F-150, right? Like, they plan these big, massive upgrades out well in advance of releasing products, and they'll go in and completely make all custom gear. And I think that binder jetting, of all of the additive techniques, maybe not, material extrusion, but binder jetting of these metal techniques is the most that you could actually customize, because, like, whenever I would work for a company that got a contract to, like, build, say, well, one that comes to mind, I did this thing out in Aurora called a company that made airbag inflators, but they had to come off the assembly line one every 5 seconds. So and it was another one of those cases, dude. We were, like, building the assembly line in 98 that was going to start production in 2001 to make the airbag assemblies for the 2004 model of Honda or something like that. It was some crazy long program. And but binder jet in particular, I think, is adaptable to that kind of thinking, where it's I'm not going to go buy 10 160 Pros, or I'm not going to go buy 5 H3s. I'm going to bring a company in and I'm going to get, like, the exact type of binder jet configuration that I need for exactly what I want to make. Because I think that binder jetting, while it's not easy, like, it's a whole lot of The Martian, it's just one engineering problem after another. And if you're willing to take the time to cut through those engineering problems, you can get to really adaptable solutions. And I think that, what the future could be is that, Ford has some custom designed binder jetting assembly line where they have some custom machines integrated into one of their bigger lines somehow, like that. It's not necessarily going to have to be a finished product from a distinct OEM.
Right. Okay. As we were talking prior, like before we went live, we were talking about, that we have people that work in metals as, people that watch, and John Stern is saying they use a lot of MIM in their products and they need high volumes, but prototyping with binder jetting could be useful if the tolerances are good enough. What type of tolerances are you hitting with the Educator platform?
Yeah, so it's well, I can't really speak to mine yet, right? Because I'm alpha and I'm just getting to the printing. I haven't even bought a furnace for myself yet, Grant. So, like, that's one of the things that my first customer, like I say, they're doing glass, not metal. So straight out of the gate, having that capability wasn't exactly top priority. Out of a typical binder jetting printer, though, you're going to see somewhere between 0.1 and 0.2 millimeters of accuracy, absolute, in an absolute sense, because they're very good at like having a tiny little bit of extra bleed, but the bleed always works the same way. You literally just wind up with too much skin, and it's usually about 0.1 to 0.2 millimeters, which becomes a heck of a lot less important once you go through the sintering process and you shrink by 21%, 21%. You know, like a lot of those things, everything shrinks too. So, you know, it is near net. But yeah, typically about 1% is about the best you can do in a well-tuned. And I say let me clarify, you know, if you think about MIM, so I heard somebody say they use MIM a lot. MIM will often talk about golf balls, right? Like they'll say golf balls ideal, or I like to make the analogy of like 6 50-cent pieces. That, like, you know, that's where it excels. And in terms of like what kind of accuracy you can get all kinds of great accuracy for prototype testing. So like there's a case study out there done by MIM Technique that was an exone customer, where they needed to like prototype some kind of newfangled T-slot nut for some kind of new type of aluminum extrusion. And before they went to full production, they needed to make about 1,000 of these nuts to see how they would perform in the application. They were able to do that and then went to production. So, you know, that's why so many of the production, all of the binder jetting production company systems are comparing themselves to MIM and talking about MIM and how we're similar to MIM, and it's just like MIM. It's because they know that, and like I said, I think I said earlier, the most successful companies right now with binder jetting in production or pre-production are companies that have some sense and history of powdered metallurgy.
Okay. So what then do you see being really the future of metal, right? A lot of companies are pushing towards that LPBF, SLM, DMLS, pick your poison for 3 or 4 letter acronyms for laser-based metal printing. Do you believe that is going to be something that continues to progress at this, you know, really hockey stick level? Or do you think that, you know, with a platform like the Educator, that metal binder jetting will become something that sees that kind of similar growth?
Oh, I sure hope so. I'm counting that I'm at the base of the hockey stick still. And, you know, I'll say this, I've been in it 20 years and I've been saying the same thing for 20 years, Grant. I feel like I'm sitting on a barrel of dynamite and nobody can find me a match.
Dude, same, you know? Though, okay?
Okay.
Like, I'm like, everybody needs 3D printing. Like the vast majority of people need some form of 3D printing in their day-to-day life, especially in their businesses. But none of them know it exists, and therefore they don't understand the value. And while $100,000 is pretty expensive, not when you compare it to basically any other competitor on the market, especially when you're going to get USA-based expert level customer support. It is a different world.
Yeah.
It is.
And for sure. But, you know, that said, it's, hey, I guess I'll say it can get better, right? Like, you know, hey, who knows? Maybe somebody, hey, Grant, who knows? Maybe somebody will take this machine, maybe not copy my design, hopefully. But, you know, one of the things that, like, I always said, if I could get a sponsor, I will make a series of videos where I tear apart my Echo Tank piezo-based all-in-one printer and turn it into a binder jetting machine. You know, like I'll run a series of classes teaching people how to go buy a $300 Epson ET and turn it into at least a full color gypsum printer or something. That's pretty cool. With the materials that it comes with, like figure out what you have to mix into the powder, whatever, and turn like the paper handler into a powder handler somehow. And, you know, like, I mean, there'd be a way to do it. I could, you know, like give it a sponsor time and money. I could figure that out. And I think that would be like a really fun series into a binder jet metal printer. Yeah. Well, I saw somebody saying that on some other platform. It's, you know, the real problem with an ender in particular is that you need an extra couple of axes. You need at least one more axis. Rigidity. Well, I mean, there's a whole
material build quality.
Yeah, well, hey, but I'll say, I'm not disgusted by the quality I get from my ender. Okay, like now I don't expect a whole lot. Like I don't put it on a pedestal, but what I expect for $200, I get for $200. I think you were saying something about that
than $200
not too long ago, but was it more in resin printing or something like that? You were like, oh, I'll just go buy another printer because at my first job, I'll pay for the printer. And if I throw it away, I still made money.
Yep.
So,
same deal for you.
Right. So for me on those, yeah, that it's like, and they're so useful. I'll tell you, Grant, I can't get over. So like the whole time I worked for X1, I was 20 years there. We never had a single plastic printer, not one in the whole place. We didn't use, X1 did not use at that time. I think they've changed now in the last couple of years, but at that time, they didn't have any rapid prototyping equipment. All they had were the big metal printers they made. That was it. Like there was no rapid prototyping.
It's funny how a company that
go
makes
through
a rapid
complete
prototyping
design
machine
cycle
doesn't do any rapid prototyping.
Could totally overlook that. I think it's because too, back in the day, there were so few companies. The market was even so much smaller between 2000 and 2007 than it is now. You viewed every other person in the additive space as your competition. Meanwhile, there was zero overlap between a Stratasys plastic extruder and an extrude hone metal binder jetter printer. There's no overlap in those markets, but you still treated those people like they were your competition, because back then we all viewed ourselves as nothing more than rapid prototypers. None of us were thinking about rapid production back then. So everybody was your enemy because they were either choosing the plastic rapid prototyper or the metal rapid prototyper, because nobody was like differentiate. There weren't enough people to differentiate yourself against, for one thing, like extrude hone or X1 in the early days. It's not like there was a number one competitor that we could point to and say, Z-Core is our number one competitor because they print chips and there was you weren't going to be an architectural firm looking for full color mock-ups of the buildings you were designing. You weren't going to come to X1 for that.
No, you weren't.
So there was just a reluctance, I think, to work with anybody back then, regardless of who they were. And that that the company X1 was so old that it was baked in those days. But then finally, I suppose once all the old timers were gone, the newer people came in and said, you guys have been stupid for 20 years. So and they finally changed and do some stuff now. But yeah, man, I couldn't believe it. Whenever I bought my first 3D printers, so like after I was let go by X1, might as well be honest about it. After I was let go by X1, I was like, all right, I'm going to go buy me some printers and see what this plastic world's all about. And
it's pretty damn good.
Like kicking myself. It's amazing. And it's like, and people talk about all these weak, clunky plastic parts. And I'm like, dude, if you know how to set your settings, PLA is plenty strong for lots of things. You might not want to leave it in the sun. I get that. But, if you really take the time to learn the software, learn some design techniques, learn what the difference between a wall and an infill and a top and a bottom and a this and a that, and really learn how all those kind of work together, you can make all kinds of great stuff. That's, like you asked me, are these parts functional? Of course they are. They work. Why wouldn't they be functional? I printed them out, and if what I need is an air duct that just like sucks air from point A to point B, and it needs to last a few months at a time, wears out, whatever.
FDM all day, whatever. Baby.
Right. I was going to say, make another one. It's going to cost you $8 in material and like 10 hours of time. And do you really want to swap out like a $1,500 custom metal pounded whatever? Yeah, no, I don't. I'd rather just print one and be done.
This is what I love about this industry.
Yeah. Well, yeah. I mean, it was such an eye opener to have my first plastic printer.
Without a doubt. This is awesome, Dan. We got to have you back when you're moving into the beta stage to see what you've learned from the alpha stage, because product development is a really cool thing. And, you're opting to, obviously your customers know, but it's an experiment at the end of the day. And
this is up front, man. This is an alpha program. This is most people try to do their alpha secret, right? Like they make some machine and then they try to be, hey, you want to try this machine out? It's really cool. But anyway, and I only have one setting. I warn my partner James all the time. James, I only have one setting, multiple wide open, so be careful. But it's like, yeah, man, this is it's really going to be interesting, maybe when we get a little bit closer to like Thanksgiving or Halloween or somewhere in there, I'll have some really great stuff to talk about.
Well, definitely keep me in the loop on that. Where can everybody find more information about the Educator platform and b.jetting?
Right, of course. So you can go straight to our website, b.jetting.com. That's b-jetting.com. And you can find out all about me. There's a whole bunch of, like my background's there and some other interviews I've done over the years, some videos that I've made. If you do a search on YouTube, you can find some stuff from my X1 days, and you can find, if you search for Bruno, you can find if you really want like a good idea of all the types of binder jetting and how the outputs all fit together. I gave a talk. You can find it on YouTube. It was to TRX. It was called Reintroducing Binder Jetting, and it kind of goes through where the company was at that point, but it also goes through all the different types of binder jetting technology and what I call the output forms of matter. We talked about two today here, like infiltrated metal, fully dense metal, but there are also, if you look at some of the product offerings from X1 and partnerships with others, that like you can take that sand. We didn't really talk about sand cast printing today and sand printing, but that sand is really some cool stuff because it's just a porous material too. So you glue the sand together, you can infiltrate it with resins, you can turn it into really hard plastic pieces, you can polish it, metalize it, like do some really crazy prototypes, and they're all made out of sand, which is really wild. So there's just so much you can do with binder jetting. And I just, like I say, whether you want to call it, sitting on the TNT or, for 20 years, we're still scratching the surface of the capabilities, like we've got some of those scratches pretty deep, but it's scratching at the surface of what a lot of this can do. So I'm very excited to see all the ways that binder jetting is going to change in the years to come.
I am as well, and we're going to definitely be keeping an eye on you. I want to do more of the professional end of 3D printing. I think, b-jetting and what you're doing there really starts to bridge that gap between what is affordable for a small business and what enables them to start competing with people that do have $1 million machines. So, Dan, thank you again for coming on the podcast.
Hey, thank you, Grant, so much for having me. This was a lot of fun. I love to hang out and geek out stuff that I'm excited about and that I love. And anytime, man. Like I said, this is great.
Absolutely. Well, Matt, we'll definitely have to have you on in the future, but I greatly appreciate you coming out. We had a good group of people here hanging out that are all really interested in this tech. So guys, don't DDoS his server with all the people going to the website. But seriously, go check it out. Dan's I linked in the description the entire PDF on the Educator. So if you're looking to get more information about the Educator platform, go take a look at it, because there's way more that we can cover on a podcast alone. So again, Dan, thank you very much, guys. And
you're welcome, Grant. Thank you.
You've been to enough of these. Do you know my outro?
Oh, man.
I always do. I always ask our guest our outro. Do you know the outro? No? All right.
I probably never get to, the thing of it is, so what I love about your podcast, it's what I usually am like listening, and then I'll hear something, and then I'll run over and have to put something in the chat, and then I'm usually, it's like, it's better than radio, right? Like, because it's like listening to NPR, like your favorite news station on NPR or something. Yeah, well, I like to listen, and so I'm really glad to come here. But no, what's the outro?
Stay safe out there. don't forget to call your loved ones. And as always, keep making awesome. With awesome tech, like B.jetting Educator, this has been Season 3, Episode 28 with Dan Brunemer from B.jetting. Take care, everyone. We'll see you next time.